Greetings and welcome to Lesson 3.4 Contingency Tables. Don't skip this important step. Go through each of your new terminology for this lesson. A contingency table is a way of portraying data so that we can facilitate calculating some probabilities. It's easier to find conditional probabilities when we have a table this way. Let me describe this table. It's a study on speeding violations and whether the driver used a cell phone or not. It's not true data, it's fictional data, but it will still be a good way of learning how to deal with contingency tables and how to read them. The column data is all about the violations. So speeding violations last year, there were a total of 70. 25 of those people used their cell phones, 45 people did not. The no speeding violations, there were a total of 685. Of that 685, 280 were using their cell phone and 405 were not. So that's the column information. The row information is all about cell phone use. The total of people, drivers, using their cell phones equaled 305. Of that 305, 25 got speeding violations and 280 did not. Drivers that did not use a cell phone, their total was 450. Of those 450, 45 got a speeding violation and 405 did not. There were a total of 755 people that were surveyed. Now we can start answering some probability questions. What is the probability that the driver is a cell phone user? The cell phone use is in the row. The total of drivers who use their cell phone was 305 out of the 755. So the probability that the driver is a cell phone user is 305 out of 755, or 0.4040. Let's look at the probability that the driver had no violation last year. To do that, we need to look at the no violation column. These are the total of no violation. In other words, 685. Out of all people, 755. So the probability that the driver had no violation last year is 685 divided by 755, in other words, 0.9073. Now let's look at the driver who had no violation last year and was a cell phone user. The great part about using a contingency table, we can find that very easily because those drivers that had no violation, they're in their own column, and we're looking for the crossover that used a cell phone. So the had no violation and used a cell phone had a total of 280 people out of all drivers, which were 755. So 280 divided by 755 is 0.3709. And that was because we're talking about all drivers who had no violation and was a cell phone user. Now let's look at another circumstance. What's the probability of the driver is a cell phone user or the driver had no violation last year? Now the total number of drivers who is a cell phone user is 305. It's that row. The drivers who had no violation last year, that total is 685. There were 685 people that did not get a violation. The problem is we double counted. We double counted the cell phone users that had no speeding violations. So we have to subtract those out. So 350 divided by 755 plus 685 divided by 755 minus 280 divided by 755 gives us a grand total of 710 divided by 755. Doing that division, we get 0.9404. Here's another circumstance. A driver is a cell phone user given that they had a violation. Because we're only dealing with those drivers that had a violation, the total of violations last year was 70. We're only talking about those 70 people. How many of those 70 people are cell phone users? 25 out of those 70 are cell phone users. So 25 divided by 70 is 0.3571. Tables are much easier when we have these conditional statements. Given that they had a violation, who's the cell phone user? Let's try another one. Drivers who had no violation last year, given the driver was not on the cell phone. So we're looking at drivers who are not on the cell phone. There were only 450. And then also who did not have a violation. That's 405 out of those 450. 405 divided by 450 is 0.8901. So you need to be careful. If it's conditional, like a given statement, then the total amount of people that you're surveying is going to change. So given the driver had a violation, you only look in the violation column. Driver was not a cell phone user, then you only look into the cell phone row. On occasion, you'll run into data tables that are missing data. Here we have a table that describes male and female hikers and where they like to hike, either the coastline, near lakes and streams, or on mountain peaks. We're definitely missing some data. One of the best strategies you can go about filling in the data is to look for any row or column that has one missing value. If you're only missing one value, you can solve some of the puzzle. So it looks like the female row and the total column are only missing one value. I'm going to go ahead and fill in my total first. 45 plus 55 will equal 100. So I can fill in that total with 100. For the female row, I need to add up to 45. So 18 plus 16 is 34. Now to find that other number, I'll just say 45 minus 34 is 11. So the female at the on mountain peak will be 11. Looking for columns and rows, again, that only have one data point missing. And sure enough, the on mountain peaks is only missing the total. So 11 plus 14 is 25. Okay. Now also, there seems to be a column near lakes and streams is only missing one data point. So 16 plus something will equal 41. So 41 minus 16 is 25. So I can fill in that blank spot with a 25. The other two, if we look at the column for coastline, it's missing two data points. But if we look at the male row, it's only missing one value, and the total row is only missing one value. So I'm going to look at these in terms of being a row and not a column. So something plus 25 plus 14 must equal 55. 25 plus 14 is 39. 55 minus 39 is 16. So the male that likes to hike at the coastline must be 16. One last square to fill in. 18 plus 16 is 34. Now that we have our table completely filled in, we can start answering some probability questions based on this data. You've reached the end of this lesson.